right, so here we are at Chapter 8, which is all about sequences and series. Before we jump into that, we're going to go do a little review of an introduction to sequences and series. So I'm calling this section 8.0. So the definition of a sequence is just an ordered list of numbers, but we could write it as a function, actually, whose domain is the set of positive integers. And if the domain is the positive integers, then the range is the actual list of terms in the sequence. So if you look at these points, which is our function, you can see that the domain 1, 2, 3, so on, is your positive integers. But the A1, A2, A3, A4, all the way up to AN, that is actually your sequence. So if I wanted to write the sequence as a list instead of as a function, this is what it would look like. It's implied when it's written in this list form that the domain is the positive integers. All right, so let's take a look at an example here. Simple sequence of even numbers, 2, 4, 6, 8. If I wanted to convert that into the function form with the points where you can see the x coordinates, 1, 2, 3, 4. So you can tell this is the first term, that's when the x value is 1. This is the second term, that's when the x value is 2. Third term is when the x value is 3, and so on. All right, so what is a rule? Well, a rule is just something that describes the pattern of your sequence in terms of n. And we usually write it as an expression with the variable n. And it represents the nth number or term of each set. Okay, so when you see a sub n like that, that is just the general nth term of a sequence. So here's our first example. Given the rule a sub n is equal to 2n plus 5, so we can call that the rule, but it is also the formula that we can use to find the nth term in this sequence. It's asking us to write the first 4 terms and find a sub 10, which means find the 10th term. So the first term, the way you find the first term is by plugging in 1 right here where you see n. So 2 times 1 plus 5. So a sub 1, that represents first term, is 7. So let's do that for the second term. Plug in 2 for n. So 2 times 2 plus 5, and you get the second term is 9. You can do that for the third term. Plug in 3 for n, and you get 11. And then we have to do this for the first 4 terms, so we have to do it one more time. Okay, so we plug in 4 for n, and we get 13. Fantastic. So now what we have to do, last part of this problem, is to figure out a sub 10. So what is a sub 10? I'm going to let you guys try to figure that out on your own. Okay, so hopefully what you did is you plugged 10 in for n, and you got 2 times 10, and then added 5, and got 25. All right, so here's an example for you. If I give you a sequence, can you find the rule? So I'm going to pause right here, and I'm going to let you guys try to figure this out on your own. It's a lot of trial and error. Use the variable n. Start having numbers added and multiplied to n, subtracted, whatever, and just play with it and test your rule. So if you get something like n plus 5, plug in 1 for n and see do you get 2. Plug in 2 for n and see if you get 1, so on and so forth. So I'm going to let you guys try to figure that out and then answer what you got. Okay, so I got this for my rule, 3 minus n. And you might have written negative n plus 3, and that's also correct. But let's take a look at how I got that. What I looked at first in my sequence is that I am decreasing by 1 each time. from 2 to 1 to 0, -1. I can figure out the next term is going to be -2, then -3, and so on. So I noticed that I was decreasing by 1 each term. That's where this -1n came from. Decreasing because it's a negative, or negative because it's decreasing, and 1 because it's decreasing by 1 each time. So then, if I just had -1n, that doesn't start me with 2 when I plug in 1 for n. So now I had to think about, how do I get 2? So since the first term is 2, the rule needs to start with 3, so I can subtract 1 to get to the next term. So if I start with 3, 3 minus 1 is going to get me to 2. So I just played around, thought about it, and got that answer. So I know that this is kind of hard for some of you. Just play with it. It's like a puzzle. Just try to figure these out, and if you can't get it, it's fine. It's not something that I would ever test you on. But here are some hints, some variations of simple rules for sequences. First one, anytime you multiply n by a number, that usually demonstrates that you're increasing or decreasing by a constant value. So if you see here 2n, I'm increasing by 2 each time. 3n, I'm increasing by 3 each time. Sometimes you have to add or subtract something to get to that first term where you start your sequence, but that's the general idea. Okay, you can take your n and raise it to a power. So like 1 squared, 2 squared, 3 squared. You can imagine the next term would be 16, which is 4 squared. Or you can have n be the exponent or the power. So it's kind of like our exponentials that we just dealt with in chapter 6. So like 1/2 raised to the nth power means I'm doing 1/2, and then I square and I get 1/4, and then I cube it and I get 1/8. You get the idea. Okay, so what exactly is a series now? A series is just a sum of the terms of a sequence. So if you look at this sequence, 1, 2, 3, 4, very easy sequence. But I can easily turn this into a series. Oh, Siri started when I said series. Ha, too funny. Okay. So taking this sequence just by putting a plus sign in between each term instead of a comma turns this into a series. But once it's a series, you can actually add up the terms and find an actual answer. The thing is that these little ... dots at the end mean that it goes on forever and ever and ever, to infinity and beyond. So really, when we're trying to find a sum, we're trying to find a partial sum, which is just saying find the sum of the terms of like the first 8 terms. So it has a definite beginning and ending. So a symbol that we use a lot of times is called sigma. This is the Greek letter sigma, and it always represents sum. But with this symbol right here, there are some things that actually go around it to tell us about our series. So here's an example. I have the sigma, and the series is the 2k, and down below it has a k equal 1. It'll always have some, whatever variable of your rule is here, that's the variable that they will have here, and it'll tell you it'll equal something. And then it'll have a number up at the top. So that's your rule. And what you're going to do is you start with this number, and you plug that number in for k to get your first term. And then you increase that number by 1, so only integers, no fractions, no decimals. Increase that number by 1 each time to get the next term, and you keep doing that until you get to this number for k that you plug in. So you end your series with that term. Okay? So let's try it out. Here is my series. This is the rule. I'm going to start plugging in 1 for k, and I'm going to keep doing that to get each term up until I plug 4 in for k. So the first term, I plug 1 in here, and I get 1 times 2, which is 2, and I add 1 and I get 3. So now to get the next term, I'm going to plug 2 in for k. So 2 times 2 is 4, plus 1, I get 5. So that's the second term. Then I'm going to plug 3 in for k. And get 3 times 2 is 6, plus 1 is 7. And then I plug 4 in for k. So this number right here, this is going to be our last term. I plug 4 in for k, so I get 8 plus 1, which is 9. And then once I've expanded all of this and got all of the terms of my series, I can actually add them together and get 24. Okay, so let's take a look at the next example. Before we expand this, I just want to ask you, how many terms do you think are going to be in this series? Okay, let's see if you're right. The first term I'm going to get when k equals 0. So I'm going to plug 0 in for k. 0 times 3 is 0, minus 1 is negative 1. So that gave me my first term when k was 0. So now, increase that by 1, I get k is equal to 1, plug 1 in for k. So 3 times 1 minus 1. So 3 minus 1 is 2. So that's the second term, when k was 1. All right, so I'm just going to keep increasing k by 1 each time. So we were at, this was when k was 0, k is 1, so k is 2, plug 2 in, I get 6 minus 1 is 5. Now I'm going to plug 3 in, 3 times 3 is 9, minus 1, get 8. I'm going to plug 4 in, 4 times 3 is 12, minus 1 is 11. And then I'm going to plug 5 in, 5 times 3 is 15, minus 1 is 14. And I'm done because 5 is the last k value that I plug in. But let's check out how many terms we have. 1, 2, 3, 4, 5, 6. So I have 6 terms this time. So if you thought that the answer was 5, you can't just look at the number that's on top, like we did up here, 4 terms, that was 4. You have to also look at where you're starting. So we started when k was 0. So be really careful about that. Okay, one last thing just about some vocabulary here. If you notice in this problem, I asked you to actually evaluate. That means to actually expand everything and then add it together, whereas this problem just said expand. All right, so if I just say expand, I just want you to write out all the terms of the series. You don't actually have to add them together. Okay, and that is it for us. Our first video lesson officially. Hopefully that wasn't terrible. I will talk to you guys later. Bye.